Quick graph y equals -4 times the cosine of the quantity 3x plus 1 by hand. This is part of the family of functions series. You will need paper and straight edge. We suggest you create grids similar to the ones at the right as needed, and press pause as needed any time during the video. Graph y equals -4 times the cosine of 3x plus 1. First, we're going to analyze this. What are the parameters and how do they affect the graph? Turns out that there are 4 parameters here: an opposite sign, a 4, a 3, and a plus 1. Now the 3, that affects the period inversely, you should recall. That is, the period is going to be the reciprocal of 3, 1/3, times the normal period, 2 pi, or 2 pi over 3. We're going to adjust the units so that the x-axis is marked off every pi over 6. The 4 and the 1 affect the y values. The negative sign reflects the graph about the lines containing the points of inflection. And so what we're going to do is we're going to first analyze and graph y equals +4 times the cosine of 3x plus 1, and reflect that graph about the line containing the points of inflection. That's the plan. So again, 4 and 1 affect the y values. We're going to multiply each y value by the 4, and then add 1 in that order, by order of operations. Recall the graph of the cosine function. Note the 5 key points of interest. The initial point, 0, 1. We're going to multiply the y value by 4, add 1, and get 5. And so our initial point will be at 0, 5. So we need to adjust units on the y-axis as well. We're going to use 5 for the y maximum and -5 for the y minimum. So we redrew it there. Pause is needed. So now we can go ahead and plot the 0, 5. The point at the end of a period is normally at 2 pi 1, but remember our period is only 2 pi over 3. So we're going to have to still multiply that 1 by 4, add 1 and get 5. But our next point is going to be at the end of the period, 2 pi over 3, comma 5. So I'll plot that right there. Halfway between two maximum points on a cosine is a minimum, normally at pi -1. Halfway between here is going to be at pi over 3, comma, whatever the y coordinate is. And we have to multiply that -1 by 4 and add 1. So -4 plus 1 is -3. So our coordinates are going to be pi over 3 down to -3. Halfway between a max and a min is a point of inflection. Here it's going to be at pi over 6, not pi over 2. That's halfway between here. Point of inflection is 0 times 4 is 0, plus 1 is 1. So that's going to be at the point pi over 6, comma 1. And I think you can kind of eyeball where the next one's going to be, but let's just go ahead and do it anyway. Point of inflection here is going to be at halfway between pi over 3 and 2 pi over 3, which is pi over 2. The y-coordinate is 4 times 0 plus 1, which is 1. So the ordered pair is pi over 2, 1. Pause is needed. Before connecting the points, recall that we need to reflect each point about the line containing the points of inflection, which is the point line y equals 1. So we need to reflect each point, each orange point about that line. So if I do this, the orange point is 4 units away in this direction, so in the opposite direction, 4 units. Here the line, or the point of inflection, stays where it is. It's its own reflection. This point is 4 units away. I'll go 4 units in the opposite direction, up. The next point of inflection stays there. And then this maximum is 4 units above. I'll go 4 units below. We can disregard the orange points. They were there just to help us. And we can connect the points. We need to get another period to the wave to the left. So let's go 2 pi over 3 to the left from each point and get 4 more points. And now we can connect the points into a wave. So starting here, part of a smile, part of a frown, the rest of the frown, part of a smile, and reproduce it on the left-hand side. Pause is needed. And this is the beautiful graph right there. The second way to do this is using a table. So again, I'd like you to pause to complete the table here. Those are our unit circle values on the axes. The parameter 3 affects the x values. It's the only one that affects the x values, and that's inversely. So we're going to multiply each x value by the reciprocal of 3, 1/3. So let's go ahead and create a second table and multiply each x value by 1/3. So 0 times 1/3 is 0. Pi over 2 times 1/3 is pi over 6, and so on. Pi times 1/3 is pi over 3. 3 pi over 2 times 1/3 is pi over 2. And the last one, 2 pi over 3. So we've taken care of that parameter 3. It affected the x values. We're going to need to change the units now along the x-axis to reflect what we got here. So we're going to hold off on doing that because we're going to have to probably change it for the y values as well. Pause is needed. So the -4 and the +1 affect the y values. By the order of operations, we multiply first, then add. So we're going to multiply each y value by -4 and add 1. So -4 times 1 is -4, plus 1 is -3. So we can now plot that 0, -3. Oh, I guess we did. We decided to do the point, all the ordered pairs first. Got it. So now 0 times -4 plus 1 is 1. -1 times -4 is 4 plus 1 is 5. 0 times -4 plus 1 is 1. And -4 times 1 plus 1 is -3. We're going to need to redraw the axes, maybe with some different units as needed. So we've got the 2 pi over 3 for the period. We've got the 5. I think we're in good shape. So go ahead and plot the points. Pause is needed. Resume when you've got them plotted. So 0, -3. Pi over 6, 1, pi over 3, 5, pi over 2, 1, and 2 pi over 3, -3. We can plot another period to the left, go 2 pi over 3 from each of those points to the left. That's the period. So the minimum will be here, point of inflection is here, maximum here, and another point of inflection there. We can now connect the points as a cosine wave. And we'll just start the smile, the frown, and so on. Now you try 2. Just graph one period of this if you want. I think I'll graph 2. Use either method or both for the practice. Pause is needed. So we're going to suggest these units right here, -pi over 2 to 9/2 pi. We're also going to go from -5 to +5. So this is the first one, 3 cosine of the quantity 1/2 times x minus 1. The -3 cosine of the quantity 1/2 x minus 1 is there, and you can see that these two graphs are reflections of one another about the line containing the points of inflection, y equals -1.